Okay, so last thing we'll look at this week, still in section 2.1, and it's on two different things, what we call arc length and area of a sector. So I'm going to give you two equations. We're going to kind of figure out what they are together, and then I'll show you how you use the equations to do some calculations. All right, so I'm going to start out with this diagram. Okay. What I have in that diagram, it's a circle, and I've drawn two angles in the circle. The angles have an initial and a terminal side. They come out from the center. They hit this edge of the circle here and here for that angle, here and here for that angle. Between those points, I drew in the red arcs. The bigger arc, I'm calling it S, and the smaller arc, I'm calling it S1. R, and I could label all these black lines as R, but they're all radii. They're drawn from the center to the edge of the circle. The symbol that you see that looks like this, that's the Greek letter theta. Usually in trig, when we have an angle that we don't know, kind of like in algebra, when you have a variable you don't know, you use x a lot. X and y are used a lot. Well, in trig, when we don't know an angle, they usually use a Greek letter. Right? Sometimes they use this one, that's alpha. Sometimes you see this one, it's beta. We just happen we're using theta. You don't have to know all the Greek letters right now, but it's theta. So this angle is theta, and this angle I'm just calling it theta 1. Okay, any questions on that diagram? All right, so first thing I want to kind of mention about this is that when you have an arc and an angle, those two things are directly proportional. Okay? Let me show you what that means. Let's say you have an angle like that. Okay? And there's your arc. Right? How big is the angle that I just drew in that circle? Yeah, 90 degrees. 90 degrees. And the arc, the intercepted arc, takes up how much of the circle? Yeah, a quarter of it. Okay. Now I'm going to draw another circle. That's fine. So I'm going to draw another circle, and this time I'm going to double the size of the angle. So I'm going to double it from 90 to 180. So here's my initial side. Here's my terminal side. And there's my arc. So I doubled the size of the angle to 180. What happened to the size of the arc? How much bigger? It doubled, right? So when I doubled the size of the angle, it doubled the size of the arc. If I were to triple the size of the angle, it would triple the size of the arc. That means directly proportional. As one thing changes, the other thing changes exactly the same amount, proportionally. All right? Questions on that idea? So, angle size and arc size are directly proportional. It works the other way too. If you make this angle half as big, you would make the arc half as big. Right? So, because angle size and arc size are directly proportional, we can set up a proportion. Right? And that's what we're going to do. Now, there's lots of ways to set up a proportion. The big thing about a proportion is you just have to be consistent. However you do it on the left, you're going to do the same thing on the right. Okay? So in a proportion, you have 4 spots. 1, 2, 3, 4. In those 4 spots are going to go these 4 things. 1, 2, 3, 4. You have an arc, an angle, an arc, and an angle. Okay? So we're going to put those 4 things in the 4 spots, and then there's lots of ways to do it. So I'm going to do it like this. I'm going to start with arc over angle. Now, if I do arc over angle on the left, I have to do arc over angle on the right. What's the other arc that I labeled in that picture? So I already used S. What's the other one?
S1.
S1. Arc over angle, arc over, what's the other angle in this picture?
Angle 1.
What is it?
Angle 1?
Theta 1. Yep. I thought I wrote theta somewhere. Maybe I erased it. Did I write that? Theta, alpha, beta?
You erased it.
I erased it. Okay. Must have erased it. All right. So there's our proportion. Now, could you flip it? Yeah, you could have done theta over S and theta 1 over S1. It doesn't really matter as long as you're consistent on each side. Right. And the only reason you can set up a proportion is because angle size and arc size are proportional. Okay? If they weren't proportional, you couldn't do that. Right? But they are, so you can. Now, the problem with a proportion is you can't have 4 things in a proportion you don't know. You've got to have some numbers in there somewhere. So let's say, just as something a little simpler, and we kind of did this yesterday a little bit. I want to create a proportion that allows me to change feet to inches. Okay? Well, I got to put something on one side. Okay? I've got to put a fact there that I know that's true about the connection between feet and inches. Can someone give me the relationship or any relationship between feet and inches?
12 inches, 1 foot.
Okay, 12 inches, 1 foot. Now that you've put in a true fact on the left, you can give me anything you want on the right. You could say, well, what about 96 inches? How many feet is that? Well, I just put in 96 inches, and then I can cross multiply, and I can solve it, right? Now, the fact that Anthony picked 12 and 1, does that limit what number I could put here? Like, could I only do 96? Like, I couldn't do 98 if I wanted to?
No, you can.
No, I can. I can do anything. He picked 12 and 1. But just because he picked that, it doesn't mean you can't put like 106 here. You can put any number you want here, or any number you want for feet. Right? The key is he just had to give me something that was true. Anything. He could have said 24 inches and 2 feet. That would have worked too. But 1 is the simplest way to do it. So, that's kind of what we have to do here. We've got to fill in one side of this proportion with a fact that we know is true. And sometimes that can be a little tricky. Like, how do you know in 1 foot there's 12 inches? Well, is this something you learned and you were taught that? Well, I taught you something about this yesterday. Okay? And this, what I taught you yesterday is going to be the starting point. It's going to be like in 1 foot there's 12 inches. But it's not going to be a relationship between feet and inches. It's going to be a relationship between angle size and arc size. Does anyone remember how big this angle has to be? And if you make the angle what I'm thinking, it automatically makes the size of the arc the same as the size of the radius.
Has to be 90, right?
We set it in radians yesterday. If you make this angle a certain size in radians, then this arc is automatically the same as the radius. Yep.
Is it like pi over 6 or something?
No, not pi. Doesn't have pi in it. That's a good guess because radians use pi a lot for other things. Yeah? 1, yes. If theta 1 is 1 radian, then it automatically makes S1 the same size as the radius. Why? Why is there 12 inches in 1 foot? There is just a fact. So, if this angle is 1 radian, then this arc is automatically the same size as the radius. That's our fact we're going to fill in right here. Just like having 1 foot, 12 inches. Okay? That's our starting point. Now, just because we said suppose theta 1 is 1 radian, because we picked a 1 here, it doesn't limit you in any way to using this formula. Just like you picked a 1 right here. Doesn't limit you as to what numbers you can plug into the formula. You can still use anything you want. You just started with a fact that was true. We're starting with a fact that's true, and that's what I taught you yesterday. Okay. All right, so let's fill in these two things on that side of the proportion. So the left side is going to stay the same. Okay? That's like, I kind of switched the sides here, but that's like this side. You don't fill in anything on that side until you know the problem they want you to solve. Okay? They'll give you some stuff in the problem. We're going to fill in the fact that we're starting with. So we've got S over theta, and we're going to fill in R over 1. Right. So there's my 1 foot 12 inches. That's like my fact I'm starting with. Now, I think I mentioned it earlier, but when you solve a proportion, does anyone remember the name of the thing you do? How do you solve a proportion?
Yeah, cross multiply.
Yep, you could cross multiply. So, cross multiply and get S times 1, which is just S. And then we have R times theta, which is just R theta. And that is the arc length formula. So it comes from that proportion, and it comes from the cross multiply. S equals R theta. So S, what is that? Well, S is the length of an arc. It could be, well, that could be anything. Depends on the problem. So let me write that down. So that's your arc length. R is your radius. And what did I say earlier? Theta or Greek letters in trig are usually used to represent angles. Yep, that's an angle. But we got to be careful about the angle. Let's go back up. I started this whole problem off by supposing that theta 1 equals that. What is that? 1 what? Radian, right? There's no little circle on it. If there was a circle on it, it would be 1 degree. But there's no circle. So that's in radians. So this formula only works if your angle is in radians. S equals R theta. So in the formula, you've got 3 variables. You'll always be given 2 of them, and you're going to find the third one. So which 2? Could be any 2. But you'll always be given 2 out of 3.
So is the theta always going to be 1 radian?
The theta is going to be whatever they tell you to plug in.
Okay.
That's kind of like saying, like right here, is inches always going to be 1 inch? No, it's not always going to be 1 inch here. It could be whatever they tell you to plug in. We just used a 1 on this side as a starting point to figure out other numbers. Does that make sense? All right. Just like if I did something like this, 24 inches in 2 feet. So does that mean you always have to put 24 inches in right here? No. You could put in any number of inches you want. This is just the fact you started with. All right. This 1 is just a fact we started with. Now that we've used it, we're kind of done with it. Okay, we're not going to have to think about that fact again because it already helped us to come up with our equation. If we didn't have that fact, we wouldn't be able to do it. We wouldn't be able to come up with a formula. It's kind of like if I said, okay, here's a proportion. I want you to use this to convert inches to feet. There's nothing there. Like, I mean, you could say, okay, in 46 inches, how many feet is that? But unless you had something over here already to start, there's nothing that's going to help you there. Okay? So you've got to start with something that you already know to be true. All right, so let's try this one. So this problem is asking us to find the length of the arc. Right, so Alyssa, if they're asking me to find the length of the arc, what letter do we usually use for that again? S. Yep. So when we write our formula, we're going to be solving for S. So that means they're going to give me R somewhere, and they're going to give me the angle. So it says, suppose you've got a circle, and inside the circle you've drawn an angle, and the angle is pi over 3 radians. Okay, and the radius is 4 inches. Find the length of the arc. So they've given you the radius, they've given you the angle. Okay, Andrew, can you remind me again, what's the formula we came up with? The equation, the arc length formula?
S equals R theta.
Yep. S equals R theta. And now we fill in what they gave us. Okay, we don't have to go through the proportion and all that stuff again. That was just to kind of discover what the formula was. Now we've got it. We figured it out. Now we just use that formula. Okay, which is based on the proportion, but we don't have to go back to that every time. Okay, so I already wrote it. So we're solving for S. And first thing I need is my radius. Max, what's my radius here? 4. Yep. Radius is 4. And Brianna, what's my angle?
The theta thing?
Yep. What am I gonna plug in for theta? Right. So if you go back and read it, does it say anywhere what the angle is?
Pi. So 3 times.
I think you're close. One more time. Could you say it one more time?
The pi
Yeah. What is it? Pi
over 3.
over 3. Yep. So pi over 3. We're gonna fill in pi over 3 for my angle, and now just multiply those together, and that's my answer. If you want, you can make 4 a fraction, and then with fractions, you just multiply straight across. Right. So Sebastian, if I multiply straight across, what do I get in the top?
That'd be 4 pi over 3.
Yep. And in the bottom, we get 3. Now, Courtney, what did I just solve for? What is that?
The length of the arc.
The length of the arc. Length. In this problem, we have to go back up and look at the units on our lengths, okay? Because this final answer needs a label. In this problem, what was my length unit?
Radian.
Radian is an angle unit. So radians is the angle. What was my length unit?
Inches.
Inches. Yep. Inches. So the length of the arc is 4 pi over 3 inches. If you wanted to know, well, what is that as a decimal? Okay, if they ask you for that, you just type it in. 4 pi divided by 3. So it's about 4.2 inches. That's the length of the arc. Any questions on that one? So this is one way they can give you the problem. They just basically write the whole thing out. Another way I could give you the problem is just draw a picture. So the question is, again, find the length of the arc. There's your arc. Okay, so once we learn the last formula we're going to do today, then you're going to have to decide which formula to use because you're going to know two of them. Well, if it says find area, that's going to be a different formula. If it says find length of the arc, that's the S equals R theta. So I would always start just by writing down the formula you need. So still solving for S, that's the arc. Cal, what's my radius this time?
It is 130. Yeah, 130. Oh, I mean 8 feet.
Yeah, 8 feet. That's going to be my radius. 8 feet. And Anthony, what's my angle?
130 degrees.
Okay. Did anyone have any
You have to
thoughts about that? Yeah?
bring that to a radian.
Yes. You have to change that to radians. If you plug it in as 130, it will come out wrong. Because this formula that we came up with wasn't based on doing anything in degrees. Okay? It's based on using radians. All right. So off to the side, we'll change 130 degrees to radians. Or you know what? We can do it right in the equation. So we have 130 degrees. What do you multiply by to change degrees to radians? Yeah.
Multiply by pi and divide by 180.
Yep, exactly. Multiply by pi, divide by 180. And if they don't say use a decimal, then we don't have to type any of that in. Let's just reduce what we can. What number goes into both 130 and 180? 10. So I could start just by doing that. So now I have 13 pi over 18. All right, so that's 13 pi over 18. And now I have, if you want to think of the 8 as a fraction, you can. The 8 is in the top. 8 and 18. What number goes into both 8 and 18? 2. So we can make it 4 and 9. Okay, so now we'll just multiply straight across. 4 times 13. And then we'll put a pi on it. 4 times 13 is going to give me 52 pi divided by 1 times 9. Okay. So that's 52 pi over 9. And now we just have to remember what we just found. Okay. What did I just figure out? The arc length, the radius, or the angle?
The angle.
So the angle was given to me.
Yeah, but you just changed it from degrees to radians, right? So that 52 pi over 9 would be the angle, right?
Well, remember it's equal to S, right? So this was equal to S the whole time. So what's S? Yeah, the arc length, right? So we were finding the arc length. Okay, that's what they asked us to find. Yes, we had to convert the angle to radians to do that, but the goal was to find the arc length. Okay? So what were my length units in this problem? Feet. So that's 52 pi over 9 feet. And again, if they wanted a decimal, you could just type that in. Any questions on how to type that in? They ask you to. Okay, so we did a couple finding S. Let's do one where they ask us to now find the angle. So this time, there's no picture, but they're telling you the arc length. It's pi divided by 4 centimeters. And the radius of the circle is 12 centimeters. Okay, so same formula. Anytime you're looking at a problem, if it says something about arc length in the problem, use S equals R theta. Okay. Right, so let's start with S. Justin, do I know what S is?
Yeah.
Okay, what is it?
Pi over 4.
Yep, arc length of pi over 4. So we're going to start with that. Equals. Next thing I need is R. Emily, do I know R?
Yes, 12.
It's 12. Oh, sorry, we have 2. Yeah. But yes, you're right. R is 12. Next thing I need is theta. Okay. Emily, up front, do I know theta?
No.
No. That's the direction. Find the angle. So we don't know theta. Okay. So now we just want to get theta by itself. Okay. How would I move the 12 times theta? How would I move the 12 to the other side?
By
Yep, by
12.
12. Okay. Doing a divide by 12 here is the same as just putting a times 12 in the bottom of a fraction. So that's dividing each side by 12. And this cancels out. And let me just see something real quick. Okay, so what do I end up with as an answer? What's 12 times 4?
48.
48. Okay. So that's my angle. Now, this formula, I said it always gives you the angle with certain units. What are the units on the angle here? Yep.
Centimeters?
Centimeters is a length.
Radians?
Radians. So do you need to put RAD?
No.
No. Anytime it's RAD, you don't need to label it. Okay? Okay. Any question on that? Now, if you saw, let's do something like this. Let's say this was a multiple choice question. And I gave you 3 choices. 12, 3.75, and pi over 48. Can you guess which answer is correct there? Yep. Yep. 3.75 degrees. Why?
Because you said it calculated.
Right. Because I did it on the calculator. The thing I'm trying to show you here is look at all these answers. Degrees, degrees, degrees. That's not a degree. So if you look at a multiple choice question and the answers are all in degrees, you would have to change your answer to degrees. This formula will never give you an answer in degrees. It always gives it to you in radians. So that's what I quickly did on the calculator, and that's how I got 3.75. So the way those answers are listed, B is correct. Now, what if I did this? Big difference. Which answer is correct now? C. Because now I'm looking at my answer choices. They're all in radians. I know that's in radians, and that one matches that one. So that's why C is correct. So just look at the multiple choice answers and see if it's in degrees or radians. Doesn't change how you would solve the equation. It just changes the last step. Do you need to do one more step like I did on the calculator and change it to degrees? Okay. Any questions on that? Okay. So we found, let's see, we found the angle, we found the arc. Let's try one where we find the radius. Okay, and I'm doing this one just as a picture. Okay, so I got the formula. That's what you want to put on your reference sheet if you can't remember S equals R theta. You want to put that on your reference sheet. Okay, so let's start with S. Abby, do I know S?
Yes, it's 13 feet.
Yep. S is arc length, and the arc length is labeled as 13 feet. Okay, let's go to the next thing, R. Megan, do I know R? No, that's the direction. Find the radius. Times. And theta. Okay, how about Matt? Do I know theta?
Yep.
What is it?
36 degrees, but you gotta put it.
Yep, nice. It's 36 degrees. But I'm just doing it kind of off to the side this time. We have to change it to radians first. 36 goes into 180 5 times. So that's pi over 5. Any questions so far? Now, my goal is to get R by itself. I can move, so I got to move the pi and the 5. And I can move both of them at the same time using kind of a trick. Does anybody remember when you've got a fraction next to a variable, what you do on both sides to move the whole fraction to the other side? Yeah.
Multiply the reciprocal.
Yep, exactly. You're going to multiply each side by the reciprocal. It's just like having this. If you wanted to get the 2/3 on the other side, you would multiply by 3 over 2 on each side. All right, so here, let's see, Jason, what's the reciprocal I'm going to multiply by?
5 over pi.
5 over pi times 5 over pi. Pi's are gone, 5's are gone. Only thing on the right is R. And 5 times 13 is going to give me 65. Okay. 65 over pi. How about Riley? 65 over pi is my what?
The integral theta? Or are you asking like
It's the answer to
the radius?
the radius. Okay? Radius is a length. It's a measurement of how long something is. What are my length units in this problem? Feet. Right? So 65 over pi feet. Right? So just because something has pi in it, it doesn't always mean that it's a radian. That's like saying because a number always has a 3 in it, it's always a temperature. No. You could have something that weighs 30 pounds. Just because there's a 3 in it doesn't mean it's always a temperature. Just because there's a pi in it doesn't mean it's always radians. You could have a pi in it and have it be the radius. You can have a pi in it and have it be the angle. Just pi comes up a lot in these kind of problems because we're dealing with circles. You could have pi in it and have it be a volume. But we're not doing volume, so it won't be a volume. Okay, so any questions on that? Okay, let's take a look at the last formula. So the picture that I'm drawing, very similar to the first picture we drew. It's a circle. Inside the circle, I've drawn 2 angles. One angle I'm calling theta. The other angle I'm calling theta 1. But this time, notice S isn't labeled. I'm not focusing on the arc. I'm focusing on the area. The area where? I'm going to erase it because this makes it kind of hard to read. But this is the area that I'm looking at. That shape right there. What I just shaded in green, that is called a sector. It's kind of like if you had a round pizza and you cut it into 8 pieces. Normally you cut a round pizza. Each piece of pizza is in the shape of a sector. You have 2 sides that are straight, and then the top side is an arc. First thing I want to figure out is what's the formula. If I can set up a proportion again, that would be helpful. So let's think about it. This is the angle. This is the area that it takes up that I had shaded in green. If I double the size of that angle, do you think it would double the size of the area? Think about if you had like, here's a 90 degree angle, takes up that much area. Okay. Here's a 180 degree angle. I doubled the size of the angle. Did the size of the area double? Yeah. So they are directly proportional. If you tripled the size of the angle, initial side, terminal side, make your angle 270 degrees, almost all the way around, it would take up 3/4 of the circle, which is triple the original, which is 1/4 of the circle. So angle size and area are directly proportional. So we can set up a proportion just like we did before. But remember, the key to any proportion is you have to know half of it. You've got to have something to plug in on one side. Okay? So we're going to set it up first and then see if we can figure out, what's my 1 foot 12 inches? What's the thing that I can start with here? All right, so I need to plug in these 4 things in those 4 spots. Anyone want to take a guess how we could set up the left-hand side?
Your area over your theta.
All right, so let's do area over theta. So Anthony had a few choices for that. Now that he picked that, we've got to set up the right-hand side the same way as the left. So what's going to go on the top? On the right?
Area 1.
Area 1. And on the bottom?
Theta 1.
Theta 1. This is where, right here, we're going to plug in something. We're not going to plug in 1 foot 12 inches because that's not what we're doing. We've got to plug in a connection between angle size and area size. All right? And I think what will help is if we go back to this picture. Okay. How big was this first angle? 90. And how much of the circle does that area take up?
1/4.
Yep, 1/4. So that was a 90. Let's go to the next one. That's a 180. How much did that take up?
1/2.
Right, so we've got a connection there. We know that if you have half the area of a circle, that's 180 degree, right? If you have a 270 degree, how much area does that take up?
3/4.
3/4. So let's go one more step. Initial side, terminal side. How big of an angle is that one?
360.
360. And now, if you have 360 degrees, how much area is that on the circle?
1. 100%.
100% of it, right? The whole thing. So 360 degrees, the area is the entire circle. So we just have to figure out a formula for the area of a circle. Okay? And I think somebody said it yesterday. Does anyone remember what the formula is for area of a circle?
Pi r squared.
Yep, pi r squared. So that's going to be our connection. If your angle is 360 degrees, or 2 pi radians, then your area is automatically pi r squared. Why? Well, because 360 degrees is the whole circle, and the formula for the area of a whole circle is pi r squared. So that's our connection. So let's suppose that theta 1 is 2 pi radians. That's an angle that goes all the way around the circle. Then the area is automatically pi r squared. That's a true fact. I mean, another fact you could use is you could say, suppose that the angle is pi. That's 180. Well, we could, if we did that, if we did half a circle, then the area here would be 1/2 pi r squared. Okay. Doesn't matter what fact you use. 1 foot 12 inches, 4 feet 48 inches. You got to just start with something that's true. Doesn't matter what. But that's definitely true. Any questions on that?
Why do you have 2 pi?
Because 2 pi is 360 degrees.
That's pi r squared.
Pi r squared is the area when the angle is 360 degrees. So our goal was to kind of come up with a connection between the size of the angle and the size of the area that covers. So if you have an angle that's 2 pi, that's the entire circle. If it takes up the entire circle, the area is pi r squared. So that's the connection. I mean, yeah, that's the easiest one to use.
That's our fact.
Yeah, I get that.
That's our fact. If the angle is 360, the area is the whole thing. And what's the formula for the area of the whole thing? Pi r squared. That comes from geometry.
Yep.
And why is 360 equal to 2 pi? That's what we learned yesterday. If you multiply by pi and divide by 180, it'll come out to 2 pi.
Okay.
I mean, if I just 360 times pi over 180 goes in once, goes in twice. That's why 360 degrees is 2 pi. All right. So now let's fill in our fact to start with. Leave the left side blank. That's the stuff you'd fill in when they give you a problem. Okay. So area over theta equals pi r squared over 2 pi. That's your 1 foot 12 inches. That's just a true fact you're starting with. We're still going to cross multiply like we did before, but we can actually reduce a little bit first. Anybody see something on the right hand side? I can, if I don't simplify now, then I got to just do it later. So I might as well just get it out of the way now.
Pi.
Yeah, what happens there?
You can just cross them out, right?
Yep. Pi in the top, pi in the bottom. Now cross multiply. 2 times a. Oh, that's 2a. And then theta times r squared. Now, my goal is to come up with a formula for area. Right now I have a formula for double area. 2 area. How would I get this 2 on the other side? So then I just have this. Yeah, divide by 2, which is the same as multiplying by what number? A half. Yep. So you can write it either way. This is how the book writes it. If you write it as r squared theta over 2, it's the same thing. So this is the formula for area of a sector. Now, we don't have to go back to the proportion. The proportion was just to figure out the formula. Now we've got the formula. We just use that and fill it in. It's got 3 variables, just like the arc length. This is your area. R is your radius. And theta, what does theta stand for again? It's an angle. And let's go back up. For my starting fact, for my 1 foot 12 inches, I assumed that my angle was in what units again?
Radians.
Radians. I didn't say suppose theta 1 equals 360. Okay? I did 2 pi. If I had done 360, then we would have had a 360 right there, and we could have come up with a formula. But the problem with that is you would have had a 360 up in the top, and you wouldn't have had pi there. So the reason I did radians is because you had a pi in the top, pi in the bottom, and then it cancels out. Okay. If you have a 360, there's no pi. It wouldn't have canceled. So it would have been right, just a little messier. So angle in radians. Okay, so same type of thing. They'll always give you 2 out of 3, and you'll solve for the third one. The trickiest one to solve for is R, if they give you the A and the theta. Why do you think R is the trickiest one to solve for? Well, it can be anything, but it involves something you would have to do at the very end to get R by itself.
You have to divide out the other variable.
So you'd have to divide everything out. Don't do this, but you'd have to get rid of this and get rid of this and put them on the other side. And then what would you have to do still?
Square root.
You'd have to take a square root, okay? And remember, there's 2 things that can happen when you take a square root. You could end up with something like this, and you need to simplify it to something like that. Okay, so we talked about that on the first day. The other thing that can happen with a square root is you could end up with something like this. A square root in the bottom of a fraction. If you get a square root in the bottom, okay, the way you fix it is you multiply the top and the bottom by the square root of what's in the bottom. Okay. It doesn't get rid of the square root. All it does is move it from the bottom to the top, that's where we usually leave it. Okay. Why do they move it to the top? I don't know. Why do they reduce 3/6 to 1/2? It's what they do. They just simplify it. All right. So when you have this, multiply top and bottom by the square root that's in the bottom, and you get this. Okay, so the top, there's not really much you can do. 3 times the square root of 2, it's just 3 times the square root of 2. But in the bottom, the square root of 2 times the square root of 2, that's the square root of 4. Well, the square root of 4 is 2. And that's why we did it, because you'll always get a nice answer in the bottom, and it's going to move the square root to the top. Don't have to worry about that unless you're solving for R. It's the only time you have to worry about it. Okay. Solving for A? No. Solving for theta? No. Okay, so the first one, we are solving for A. Find the area of the sector. All right, now we know both formulas. I've given you guys the arc length one, I'm giving you the area one. You have to decide which one to use. Okay. Which formula is this going to be? Arc length or area?
Arc length.
Yeah, because the problem says, no, wait, did you say arc length?
Oh, yeah.
No, you're trying to trick me, don't do that. So, let's go with the second option because it's not the first option. So find the area of the sector. Okay, area. Use the area formula.
Yep.
So let's write that down. What is the formula for the area? A equals.
Half radius squared.
Yep, half radius squared times theta. Okay. It says find area, so you don't know that. You know the 1/2 is, well, 1/2. And then R. What's R in this problem?
4.
4. Fill that in. Don't forget to square it. And theta?
Pi over 6.
Pi over 6. Is that in radians, or do I have to change it to radians? It's already in radians. I know that because there's no little circle on it. Okay. Pi over 6. Okay, so we're going to do a couple things in one step. What's 4 squared?
16.
And then half of that. So we have 8 times pi over 6. So I simplified that whole first part to 8. 8/6 reduces to
4 over 3.
4 over 3. Okay, and that's our answer. And what's 4 pi over 3? It's the
Area.
It's the area. So we go back up. Okay, and be careful. Based on that picture, what label should I put on that? Yep.
Centimeters squared.
Yes, centimeters squared. Because it's an area. Okay. Any questions on that? Okay. So that's finding A. Let's try one where we have to find R. So remember, this is the one where square roots can come up. Now, it says find the radius. I don't see the word arc length or area on the board anywhere there. So how do you know if this is an area problem or an arc length problem? There's enough information on the board to figure that out, even though the words area and arc length aren't there. Megan?
It doesn't give you the arc length, because you're looking for the radius.
Well, how do you know the 8 pi over 3 isn't an arc length? Maybe I just put the label like on the inside, although that would be confusing if I did that. But there's a real important thing to look at that tells you that that's not an arc length. Yeah, Brandon?
It's squared.
It's squared, right? Inches squared means it's an area. Okay, I know I'm doing something with area. So let's write our formula. Okay, and Grace, what is my area here?
The area,
Yeah,
I don't know.
so that's given to me. It's one of the things that they're giving me in the diagram.
Oh, 8 pi over 3.
Yeah, right, we know that's the area because it's inches squared. So 8 pi over 3. 1/2 stays the same. We're finding the radius, we don't know it. And Emily, how about my angle?
45 degrees.
Okay. Any thoughts about that angle?
It just says like it has the degree mark on it, so.
Yes, it does. It has the degree mark on it. Yep, Elizabeth?
That's be converted to radian.
You have to convert that to radians. Okay, when you convert it, you'll get pi over 4. Okay, so your angle is pi over 4. All right, so on the right-hand side, I really see 3 things we need to get rid of. We need to move this to the other side, this to the other side, and then get rid of the exponent of 2. Okay. Let's start with the pi over 4. We kind of had something like this before. How could I move the pi and the 4 to the other side at the same time? Multiply by the reciprocal. 4 over pi, 4 over pi. Pi's are gone, 4's are gone. So on the right, you still have this. What do you have on the left? Well, actually, what happens on the left? Let's see. Yep, pi's cancel there. Okay. Now what do you have on the left? 32 over 3. Yep. Okay. First thing, I still need to get rid of this 1/2. So you can kind of do the same thing we just did again. How would I get rid of the 1/2?
Multiply by 2.
Yeah, what's the reciprocal here? Yeah, 2 over 1, or really you could just say 2 times 2. If you want to do 2 over 1, you can. That's gone. And now I get 64 over 3. And now my last step. How do we get rid of having an exponent that's 2? Yep.
Square root.
Square root it. Square root on the right, square root on the left. Here, cancels. Now, when you square root a fraction, all you have to do is square root the top and the bottom separate. The top actually comes out nice. What's the square root of 64? 8. The bottom doesn't come out nice. Okay? Comes out to square root of 3. It's unlocked.
Is it?
So yeah, 8 divided by the square root of 3. So, what's wrong with that? Right, so this isn't really trig, this is algebra, or not even algebra, it's like simplifying arithmetic. We just want to get that square root into the top. So what do you multiply top and bottom by to do that? Yeah. So that's what just kind of makes this problem a little bit of a pain, is all the square root stuff at the end. Okay. And normally I would just do the answer in that step, but I'm writing it out step by step. So now you get 8 square root of 3 in the top. What about in the bottom?
3.
3, yeah. And that's my radius. So I say, okay, radius is length. My lengths in this problem, inches, not inches squared. Okay. Length is just inches. Any question on that one? So that's probably the longest type. Any questions? We just did R, we did A. Is there any question how you would solve for theta? It'd be, R would be easier because they give you that. And then you just square it, multiply it by a half, and you can move it to the other side. So no questions on how you would do something like that? Okay. So a little bit easier again because you have R. All right, so in the homework, the last couple problems are word problems. Okay, one of them is about a clock. Okay, and they're going to say something like you have a minute hand starting at 12 and moving to 4. And what they're going to want to know is how far the tip of the minute hand moves as it goes around the clock. Well, first of all, what kind of question is that based on what we learned today? How far the tip of the minute hand is moving?
Arc length question.
That's an arc length. Yeah, it's an arc length question. So if they give you the length of the minute hand, let's say that it's 5 inches. The length of the minute hand is like your what?
Radius.
That's your radius. It's the distance from the center to the edge. Okay, so that's your radius. What else do you need to find the length of the arc besides the radius? You need the angle. Well, angles on a clock are easy to figure out because everything is evenly spaced. So you've got to figure out the angle between 12 and 4. Anyone think they know what the angle is? Yes?
30 degrees.
So this angle right here is a 30-degree angle?
Yeah, wouldn't you do 360 divided by 12?
Okay, so 360 divided by 12, I agree, that is 30. So on a clock, that's 30
Yeah,
degrees.
that's more than 90 then.
Yeah, that's more than 90.
Yes, so.
But that's a good way to think about it. It's 30 degrees every what? Yeah, like every 5 minutes or every hour, depends on how you're looking at it. But yes, each section is 30 degrees. So we have 4 sections. So how big is that angle? That's a 120 degree angle. 120, 150, and then if it was pointing at 6, it would be 180, halfway. All right, so that's just kind of a hint on that one. The other problem they're going to give you is about a pendulum. Okay, just kind of swinging back and forth. As the pendulum swings, they're going to want to know how far the tip of the pendulum moves. What kind of problem is that as it's swinging?
Arc.
That's another arc length problem. Okay? As it swings from here to here. If it went all the way around, it would make a circle. Okay? But it's just swinging back and forth. Now, they'll tell you the angle. Right? They'll say like the pendulum is swinging 20 degrees. So they'll give you that part. How about the length of the pendulum? What would that be? That's your radius. Okay? The pendulum is mounted here, distance from where the pendulum is mounted to the tip of it. That's the radius. So they'll tell you that. So they'll give you the angle, they'll give you the radius, and you just have to find how far the pendulum is swinging. Okay? So just a couple hints on homework questions. Okay. So any questions on arc length or area of a sector? All right. So that's homework. Okay. Remember, test tomorrow. distance formula, midpoint formula. Okay, definitely want to know those. I want to make sure you know how to convert degrees to radians and radians to degrees. And the third we did today, arc length. And the fourth thing is the area of a sector. Those are the topics that are on the test. Okay, again, you can have a reference sheet for this test as long as it's this size, 8.5 by 11 paper or smaller. Handwritten, but you can write on both sides if you have that much. I don't think you really have that much though. And you've got just a little over 10 minutes left. Okay, so now if you do have any questions, since after school is going to be kind of short today with the back to school night, now's a good time to ask me anything you want to know that you're thinking about.